Hello, everybody. It's a pleasure to welcome you for this paper session on renovation today. We have 4 topics to share with you today. All those topics are on renovation projects and research projects. And we will beginning with Valentina Marino for the GBC. I will make her presenter. And if you have any questions, you can ask your question in the question toolbox. And I will ask all those questions out loud after each session to the presenter. So here, so Valentina, yes, it's your turn now. Thank you.
Thank you, everyone. Good morning, everybody. I'm happy to open the session of this morning about renovation. I will leave time at the end of the presentation for any questions, so don't hesitate to ask. Okay, so today I'm presenting a project, a European project funded under Horizon 2020 that is called Build Upon Square. I've already presented this same project that was just launched the last year at SP19. So at the last year, I've launched the project basically in this framework, and I'm happy today to present the results we have obtained after more than 1 year of the project. The project is aims at supporting public authorities into the assessment of the impact of building renovation at the local scale. And how does it do it? By the definition of a multi-level impact framework that assesses the impact of renovation actions held at the local scale in the framework of the national objectives of the long-term renovation strategies. As you know, by March 2020, member states had to present their long-term national renovation strategies that integrate and improve the national renovation strategies that were given by the states almost 3 years ago as the second version. These long-term renovation strategies are required by the EPBD under the Article 2A. The idea behind Build Upon Square project is to align European, national and local objectives and try to find a framework of indicators that can assess the impact bottom up from the local scale to the national to the European one, to see whether the actions that are normal renovation actions that are mainly undertaken at the local scale, at the city scale, contribute or not to the national and European objectives, and how much. Normally, the most of European cities, and at least the most of Italians one, report under the CCAP, under the Covenant of Mayors initiative. And there are some parallelism between the two initiatives, the long-term renovation strategies requirements and the CCAPs, even if there is not a perfect match between the two initiatives. In fact, for instance, the long-term renovation strategies have an objectives at 2050, whereas the CCAP, it has it at 2030 of at least a 40% reduction of greenhouse gas emissions. Both of them interest the building sector as a whole, but under the CCAP, cities define specific initiative, whereas the long-term renovation strategies require milestone and targets for the different part of the building sector. Monitoring is a let's say, an important part of both of the initiatives. And the monitoring activity can actually be run in parallel, as both of the initiatives require a 2 years monitoring of indicators and of impacts of the initiative. Therefore, there could be some way of, in our view, there's some way to align the objectives that already are placed by the cities at the local scale within the framework of the long-term renovation strategies for the renovation of the building sector. What is the concept that supports the Build Upon Square project? Well, it is the idea of a policy feedback loop. So ideally, if all the cities at the national scale adopt the framework of indicators, they can report after some common impacts, such as, for instance, we will see later the indicators, but as energy efficiency, money spent, emissions, job position generated. If all the cities report under the same framework, then results can be compared at the national scale. This means that the policies that are led by national governments at the local and national levels can be analyzed and assessed in order to see whether they can improve and come back again to the city level with new policies that are then more effective because are supported by impact data results. So this creates a positive loop where all the information that are collected at the local scale are valuable at the national level and go back to the local one for policy improvement. So we work with cities to support them in their renovation objectives. And we work in the Build Upon Square project with 8 European cities that you can see in the slide. For the Italian case study, we work with the city of Padova, but the partners of the project are almost all green building councils, so association as the one that I represent, that are associations that represent the full value chain of the building sector in each country. So we have 8 countries in the project, and we have other 2 organizations, Building Performance Institute of Europe and Climate Alliance, who are both involved in building renovation initiative evaluation at European scale. But at the national level, Green Building Council do not work alone, but collaborate with some steering group that are made up of national experts that consult us in the definition of the indicators and how to apply them at the national level. In our steering group, we have Enea, we have the Istituto Superiore della Sanità, we have ISPRA, so we have some municipalities and some private actors as well, like Edison, for instance, or SINLOC, who are all stakeholders who represent the different actors of the value chain. And also that represent the major organization at the national level who have a say on the national renovation strategy. We do not have only pilot cities, but we have also at least 3 follower cities for each of the country, for a minimum of 24 follower city of the project, who will, in a second round of the testing activity, will also try to use the framework that we have proposed. So how this framework is working, because in this first and last year of project, we have developed this framework. So we started from the analysis of the SDGs and of the EU priorities in terms of energy efficiency as set by the European, like the PBDs directives. We went through the national objectives of the renovation strategies that were already in place, And we set national and local objectives under 3 categories: environmental indicators, social indicators, and economic indicators. As you can see in the table shows just environmental indicators at the local scale, municipal scale, as related to the European objectives of the PBDs. In this case, among the environmental indicators, I can list the reduction of direct annual CO2 emission, the reduction of the final energy consumption, the calculation of the annual renovation rate for all the building sector, and so on and so forth. At the social category, we have all the indicators that are related to the wellness and comfort of people inside buildings. For instance, and also the topic of energy poverty, as we decided to include it as a social issue instead of only an energy related one. So indoor comfort is evaluated through heating and cooling demand, and also energy poverty has been addressed as a number of percentage of households having arrears on utility bills. And also a social part was also due to empower citizens into private retrofitting their homes. So how many people are able to actually retrofit their home? And finally, the third scale, the third category is the one about economic indicators. Economic indicators normally collect all the data that are due for the financial incentives and aid received by local and national governments, and also by private sector, to increase the rate of renovation activity. And the aim is to address how these funding are spent, if they are effective in increasing the renovation rate. And also another important topic is the one of how many jobs are created due to the building renovation, and how much competence is built around the renovation activity for public authorities and building construction operators. So we have produced a series of reports while we were developing the framework of indicators. One of these is a national report, one for each nation, that reports actually what if the data that we are asking through the framework are already analyzed at the national level. As you can see from the table, this is the table at the national scale. From a first review at national level, very few data, the one with the green circle, were already collected in some of the countries, but most of the data were not collected, and also a good part of them was collected, but in a different way than how it is asked by our framework. And the situation is quite similar also at the national, at the local level, where the amount of red circles is even more, that represent that very few data are collected at the local scale by cities on building renovation indicators. So this means that actually municipalities will have to work a lot to introduce this type of indicators in their normal practice. Then we produced other reports that collect best practices in terms of renovation measures, and we published this, for instance, this report starting the renovation wave, in order to support the European Commission renovation wave initiative within the Green Deal of the European Union. In the other report where we collected measures, we selected finally 37 measures that across country can support each other into the use of these indicators by the use of databases, registers, statistics, or interactive maps in order to share the knowledge across countries. And also we asked GBCs to work with the national steering group meetings in order to create some kind of pathways to understand how the use and the integration of these indicators was possible at the local level and at the national one. So we produced this kind of schemes in which in this case is the one of the Hungarian GBCs, where we understood where we could collect data and how we could group them together and provide them to the local authorities in order to feed a bunch of indicators in the framework. This is just a representation of some of the initiatives that were collected instead in the Renovation Wave report that is public online on the World Green Building Council website, but also on our page in GBC Italia website. And finally, we produced the guide for public authorities for our pilot cities to start the testing phase. Basically, the major, let's say, ways we would like to adapt the use of this framework within the normal activity of the public authority is identified into these points. So the municipality need to align the framework to the current procedures in order to facilitate its use. It is suggested to have a monitoring activity that is aligned to the one of the CCAP or the CIAF. The fact that the monitoring data are to be preferred to calculated data, at least in the long term, if not possible at the very beginning. And also there is an open question on who is taking care of the update of the indicators and the methodology, if it cannot be adopted by the national scale. And if the monitoring activity can be different across country, and if these data are still valuable for the European level. And to conclude, at the moment we have we are running the testing phase. In fact, all the GBCs involved for each GBC one pilot city, who are actually testing the indicators of the framework and understanding at which point they are able to collect data and to express their policies through these indicators. The Italian testing phase is taking place this week. Actually, we will start tomorrow afternoon. The city of Padova already have produced an internal report in which they analyze one by one the core indicators of the framework that I showed you before, and we will discuss in the coming days the results. The idea of the project is that these pilot cities try somehow to integrate the framework into their CECAP reporting system. And in order to have a clear, let's say, specification under the CECAP of the renovation activity within the city level. And then we will try to propose the same framework at the national scale and at the European one in order to have, let's say, a trace, to have a reference across the cities of the same indicators to see how the renovation activity grows in Europe. And from my side, this is what I wanted to present today. I really thank you for your attention, and if you have questions, I'm happy to answer.
Thank you very much, Valentina, for this great presentation and to share the work you have been done. If the other panelists of today have questions, please feel free to ask your question here. And there is, for the moment, just one question about the testing phase. what is the amount of testing you will do? Do we plan to test only in Italy or in multiple countries? Or
yes, for sure. Okay, the testing phase takes place in all the as a first round in the 8 pilot cities of the projects across Europe. Then we have the follower cities, so 3 per each country. So we are speaking about at least 24 cities who will also participate to the second round of the testing phase. So, from there on, we will ask to more and more cities to try to test and use the framework. So we are really planning a European-wide testing of the indicators.
Okay.
And,
okay.
Yeah, and I can add that we have also the Climate Alliance with us. That is actually one of the companies who develop who assist actually cities during the CCAP procedure. Therefore, they will propose also to their network to use the framework as well.
Okay, and I allow myself to ask a question also to complete that. Do you need to adapt each indicator for each country, or you can use the same indicator for all the countries all over Europe?
More or less. We have decided, what I presented today is just the core set of indicators that is the same for all the European countries. Then we have actually a wider set of indicators because some of the countries like us, like in Italy, we needed for some specific issues. For instance, in our case, the historical value of buildings is quite important, whereas it is in the renovation initiative, whereas this is not for some other countries. So we included some specific indicators for cultural value, for the seismic risk, and some other important points at Italian level, and so did some other cities. But actually, the trend of the other pilot testing that has already concluded in some other countries is that also the core indicators that we proposed are already too many. So probably we will indicate some, let's say, very core indicators, some small reduced number of indicators that will be, let's say, mandatory for all the European cities, whereas each city can decide if using more indicators according to their local needs.
Okay, that makes sense. Thank you for sharing your experience. If there is no other question, we will jump into the other presentations that we have today. It's the session 2 is Mohamed Elagiry for R2M who will talk about digitalization of the residential building. So I will make you presenter. So to share your screen here. Thank you. Thank you very much.
Could you please confirm me that you can see my screen?
We are not seeing your full screen, but the 2 screen is black.
Okay. Now?
Yeah, that's perfect. Thank you.
Okay. Hi, everyone. Thank you for joining us today. My name is Mohamed Elagiry, and I am Research and Development Manager in R2M Solution. I will present for you this paper today that we did within the project BIM4N, which is a Horizon 2020 project. The paper is titled "With a Methodology for the Digitalization of the Residential Building Renovation Process through IDDS Ready Workflow," which is Integrated Design and Delivery Solution. So as you already all know, that digitalization now is a fact, so we cannot escape from transforming our industry to digitalization in a digital form, because there are thousands of information are generated, and we have a big challenge to transfer this information that we collect into useful impact in the society. And if we just zoom in a little bit on the construction sector, we have big problems in this very old industry, because it has a very low productivity rate, very low use of digital tools, and also very resistant to adopt these tools. And talking about Europe, we have around 40% of the building are existing building that need renovation, and this generate around 38 of the green gas house emission. BIM, of course, is one of the digital tools that we can use or trigger these problems, because it is a collaborative process involving many stakeholders, and also that generate a semantic model that describes the building life cycle. So it allows a more efficient and collaborative integrated design among the stakeholders. But the problem is that many of the sector is around 99% of the sector are small companies that consist of 10 employees. And these small companies, this 99% of the whole industry, generate around 60% of the sector. So this digital transformation or BIM technologies, if we want to okay, let's transfer all our industry into BIM and so on, it is not easy, because this SME that doesn't have the resources, doesn't have the requirements needed to make this digital transformation. And this is why BIM4N is there. BIM4N is basically develop these tools to specifically target small and medium enterprises. And it is based on 4 innovation pillars. The first one is we develop a digital driven workflow. So we check what is there and what is the process required to deliver specific use cases, and we design a digital workflow, make it easy to adopt this workflow, doesn't make us and try to not think too much about what we have to do. It is there ready for you. And then we develop innovative tools based on open standard to integrate into this workflow. And we collect all of these tools into one access top platform, which take me to the 3rd pillar. And finally, we have pilots as a testing and living labs where we test all of these methodologies, all of these workflows into that pilot. As I mentioned, and this paper will speak basically about how we involve the Open BIM methodology in our project, and specifically in the definition of the information delivery manuals. And why we choose to depend on Open BIM methodology, that's basically to depend on open standards that allow a neutrality of vendor neutrality. We don't need to depend on a specific tool or a specific standard or a specific closed box. We need something open for everyone, specifically for the small companies. So basically, this paper will have a BIM model in format of IFC. We need to deliver what we need exactly from that BIM model, translated into employer information requirement that is translated into information delivery manual, and then we define the MVD, export this entity from the big IFC, and this entity or this specific use case will help us to process in the other continue in the workflow of the renovation. And the methodology, which we did also in this paper, is very simple. So we define the stakeholders, and then we define all the process maps, and we say, okay, this has to be done first, and this has to be done second, and so on. And each one of them generate what is called employer information requirement or exchange requirement. This exchange requirement afterwards transfer to exchange data, and this exchange data will be the substance or the input for the model view definition documentation. So the process, starting from the stakeholders, we did define who we need to collect data from, and we did online surveys, and we did interviews and workshops. The outcomes of the survey was really helpful and interesting. We did the survey for months, and then we a couple of months, and we have a total of 230 results, and around 60% of the participants have no experience about BIM, and this is a big number. The stakeholders were among designers, public administrator, industrial or products providers, and it was among many countries. Then we did some interviews and workshop based on a specific structure. And finally, we take all of that input and we had defined use cases and the main barriers that against this renovation, and also the requirement to be applied in the IDDS letter. I will give you an example for one of the use cases. So you can see this table here where we have defined all the phases of the renovation. So it's starting from the strategic definition, data collection, diagnosis, and so on. For each process or each phase of these phases, we have specific tasks. And for each task, we have actors who are the stakeholders involved in that specific one. And in order to do this task, he needs this information. And as a definition of the barriers that I think also many of you know that many barriers exist to adopt BIM in the industry now. For example, many believe that it is very expensive to use BIM, or the labor, I need very high quality labor and skilled labor, and this is not really exist. Or they say, okay, there are many stakeholders involved in the process, and it's become complex, and we are already used in a specific process. And also the regulation of the public and the awareness in general about public authorities and so on, that all affect or make barrier against that. And main requirements that we need to overcome and we need to achieve in our IDDS platform, which we have to integrate the end user from the beginning. So the stakeholder have to be involved all through the process. That be also in a digital platform to share the information, and also continuous operation of the process, and through the use of different tools. So we have a smooth transition from tool to another tool. And the database of the existing building need to be available for all the stakeholders. And this is all have to be shared in a cloud-based platform. So one of the use cases, which is, as you can see here, like there are different also typologies of renovation work. So there is someone who will only renovate or will make a refurbishment of the internal inside his internal design of his building, or someone will make a renovation for the envelope, or make a deep renovation, so make a structural intervention as well, or only changing the services. So for each one of these typologies, we have defined a specific requirements. So if we will speak about only one use case, which is the facade retrofitting, which is under the intervention of the envelope. So we have did all the required workflows and who is the source of this information that applied to this use case. And then we insert this information inside our process map notation that we will see it later in our presentation. And this is an example for the process notation map. And it is basically standard to represent all the process happen. So you have all the actors, all the stakeholders here, from the owner and designer and architects and so on, and for each one of them how he is involved in this process and what is the requirements he needs. So, and this is the most important thing for us, is to define the exchange information or the employer information requirement or the exchange requirements. Just to give an example of one of the actors, which is the architect. So the architect is involved in the data gathering, and then diagnosis, and then conceptual design, technical project, and then the construction. How he is involved in each one of these phases. And then we have the information required to complete this phase. So, for example, if an architect is doing data gathering, so he needs to go to the site and he needs to collect data and make an inspection report, and then he makes the diagnosis. So he takes this report and see it is enough, or he needs to collect more data and continue in the process and so on. Then this is all reports. So the diagnosis become a diagnosis report that is issued by the architect. So we need to define who is the issuer of that document, and then who is the receiver. So the owner will receive this information, and so on. This is all applied for each process inside the building. This is all give us to this important phase to define the information delivery manual by defining all the exchange requirement and all the exchange data. And finally, after you define the information delivery manual, it is easy to define or generate the MVD documentation, which is just a subset from the IFC schema. As I said, you don't export an IFC file, you export an MVD. Just to simplify the meaning. So as a conclusion, we know that the IDDS digital workflow is designed to support the definition of the system architecture in order to define the model view definition as a subset of the IFC schema. And this is needed to satisfy one or more exchange requirement in the renovation process. Moreover, the IDDS workflow enable an interoperable and efficient renovation process by means of bringing together all the involved stakeholders and the software tool. So you make integration between the requirement of the stakeholders and the requirement needed from the software tools and mix them together. And this will take me to the end of my presentation. Thank you. And this is my email. And please, if you have any question, let me know.
Thank you, Mohamed, for this great presentation. There is no question so far from the audience, but I have one. You talk about the fact that it could be integrated with other software. You mean any BIM software could plug your solution, or I'm not sure. It's not very clear for me.
Yeah, so in general, also inside BIM4N, we have different tools that is used. So you have a tool that, for example, enrich the BIM model and add some information that is needed to complete the decision making. There is also a tool that make an energy simulation, or a tool that make all the energy audit. So for each tool of these tools, you have you need a model that has specific requirement in order to achieve a simulation or achieve an output of that tool. So this overview of tools, you need to know exactly what you need from the models for each one of these tools.
Okay. So you mean the BIM for renovation project, everything is very interoperable and can communicate together. Exactly. But on other software on the market, it's not always compatible.
No, it is still compatible because we are working with, as I said, open BIM standard. So you have an output IFC file, but the thing is, IFC file is something very complex. Imagine that you have very big file. You have all the data possible. You cannot process all this data in each tool. So you just need to define what you need from this data for each specific tool. And that done through definition of the MVDs.
Okay. Thank you very much, Mohamed. Here from me. There is no question so far, but you have give the attendee your email. So if they have questions, they can reach you directly. The next section, so section 3 of today, will be a presentation from Valentina Marino and Giacomo Bergonzoni. I will make Giacomo presenter right now. And we talk about another subject on the renovation process, digitalization and technology to reduce the energy performance gap. So thank you, and I let you make your presentation.
Okay. Thank you. Do you see my screen?
Yes, that's perfect.
Okay. 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 Good morning, everyone. Today I'm going to present the assessing building compliance with sustainability rating system through BIM-based approach. And I developed this presentation with Mohamed and Valentina, Mohamed Elagiry and Valentina Marino, that speak before me two other presentation. And today in this presentation we are going to speak about the green BIM state of the art and the BIM lead intersection, and how many lead credits can we automate with a BIM process, and BIM for lead case study and future development needs for BIM and lead integration. So starting, we have to clarify what is green BIM. And that is a model-based process of generating and managing coordinated and consistent building data that facilitates the accomplishment of established sustainability goals. And this definition and this concept is quite similar to the BIM 7D concept that is defined in the UNI 11337, that is the standard of BIM in Italy. And they in this standard they define the BIM 7D like simulation of the building of its elements according to the sustainability like economic, environmental, and energy of the intervention, as well as the space, time, and production costs. So the idea that with a BIM model and with a BIM process is possible to simulate and generate and manage all the data that are important for design a sustainable building. And for this reason, we find an intersection with the LEED. LEED is Leadership in Energy and Environmental Design, and is the most widely used green building rating system in the world. So we use LEED for an example of rating system, but there are many more like BREEAM, like WELL, PEARLS. There are different, and but the discussion that we are going to do with LEED sure is possible to do with the other rating system for sustainability. And we are going to understand what is LEED in particular. We have 5 rating systems for different type of building and intervention, like building design and construction, interior design, operation and maintenance, neighborhood development, houses. And for this 5 rating system, each one is subdivided in different credit categories or credit criteria. There are location, transportation, material and resources, water efficiency, energy and atmosphere, sustainable site, indoor environmental environment, innovation, and integrative process that are like more design categories. how does it work, this LEED rating system? The idea is to watch the building and the design in his complexity, like an organism, and give a credit and points for different categories, like location, and water efficiency, energy and atmosphere, and other, to find a way to give points as objective points to find to say that this building is sustainable. So if you see how this LEED rating system is differentiated in these categories, each categories has different sum of point that we can achieve. The sum of this point of this credit in each categories is 110. This is an example of LEED certification that you can find online, because all the LEED certification are published in the LEED website, in GBC website. And as you can see, this building is LEED Gold and have 13 point of 26 for sustainable sites, 8 of 10 for water efficiency, and you can see how this building has reached the LEED Gold certification. If your building can achieve the more than 80 points, you can earn the platinum certification, that is the high level certification. So what are the intersection between BIM and LEED is essentially efficiency, quality, and sustainability. And if we look at the research paper and the AC industry project and the software industry, we can find that all this different industry, or this different typology of research, each one go to the same direction. If we watch the research paper, we have we did a research to find how many paper about BIM is about also green BIM, and we have a 5%, and from this 5% there are very interesting article about LEED and BIM. In the project for the AC industry, we have a lot of projects that have this both concept in the same time. Like if we go to the Turner website and we search for BIM and LEED project with the filters, we can find 139 projects, and in Europe there are different example of BIM design project that are certified in LEED, like the Bulgari factory in Valentina, that is from Open Project. And like in the software industry, like from 2006, like Autodesk did dealing with GBC to develop software specifically for lead credit calculation. And the same way did also Bentley and his virtual environment design builder. And there is some tools in these different software that help the designer to calculate this credit. So all this all this research and this project go to the same direction, that is automation of lead credit calculation, because is very useful find a way to automate the calculation, help the designer when they design the project to automate the verification and do a better design. But right now it's not yet completely automated. So the only way to reach the automation, or to find a way to verify and calculate this lead credits, is the interoperability between different a lot of different software. And this is very time prone, because it's a lot of time to do this, because also in the Green BIM book from 2008 we have found that 50% of the time it takes to build and analyze an energy model is spent simply recreating the building geometry in a new application. And this problem still exists right now in 2020. So there are interoperability issues, and we can we can choose two different way, like closed BIM and open BIM. The closed BIM is with the specific software that different software houses have developed to lead or energy lead credit calculation, or more in general energy calculation. But it's not possible to use it for each kind all the lead credits, because not all the lead credits are for energy simulation or solar analysis, but there are different, like water efficiency, site and many more. So we have to go to the open BIM way, and the open BIM way most of the case is not bidirectional. So we can develop our model and put our BIM model in the analysis tool, but if we do some modification, revision in the analysis tool, we have to go back to the BIM tool and re-export the IFC model. And there are some issue for me from this process. We did like an experiment, like a test in modeling this engineering faculty in Bologna in Revit, and export it in GBXML, that is interoperability format for green building. And we discovered some problem to translate the openings of the BIM model, because the BIM round trip that Raphael Sachs explain is not yet reached. So it's not the BIM round trip is not right now possible. And so to enable the bidirectional interoperability is useful. Use also other visual scripting tools and tools that are allows the designer to put the data in from software to another in a more free way and a more specific way for the specific project, and solve some issue that interoperability right now have with IFC, GBXML, and DXF. So the way for total automation right now is start from a BIM model and use IFC, Dynamo, or other visual scripting, using time to find a schema that help us to put all the BIM data in the other software and go back to the BIM model and allow us to have this process. But for this reason, from 2010, there are different research paper and other resources that we can find in online, in conferences, that many people start to research how many lead points can we reach using a BIM authoring tool, so using a BIM software or a BIM process. For example, this is a table from a research paper, and this other is from a presentation of Lombardini 22 from Italy, and they found that there is a percentage of lead credit that is possible to reach in a BIM process. And in Open Project, we start with this information. So how many lead credits can we automate in a BIM process? And also add also a new information. So an information that is useful for the lead AP at the initial stage of the project, and the lead AP, so as you said, professional, is the professional that have to decide how many credits is possible to reach, and what is the certification that is possible to reach, like the lead gold or lead platinum or the lead silver. And we developed this BIM for lead metrics that is a spreadsheet and give an objective value of much is suitable the BIM process for the specific lead project. So we give we invented this BIM for lead rating, an objective value of much is suitable the BIM process for the specific lead credit. And we give this BIM for lead rating for each credit for each lead credit. So in this way, we can communicate to the lead AP how difficult is reach a specific credit in a BIM process. If it is easy, or if it's thought is difficult, and so the lead AP can understand and can decide which lead credit is better to reach in a BIM process. So the BIM for lead rating 0 is a lead credit that is impossible to verify inside a BIM authoring tool. And the 1 is when you have to export in IFC or GBXML to verify it. It's a long time to comport some experience and attention to do it. So we give only 1 point. And for example, the energy and atmosphere credits, you have to calculate the performance of a baseline building and compare it to the design building performance. We did this example is for Lombardini 22, and they use the BIM model to export in GBXML from Revit to GBXML to his virtual environment, and they did this energy simulation and find that the proposed building is better, 20% better of the baseline building, and reach in this way 8 points. You can use also, if you have a BIM for Lead rating 2, you can use the BIM authoring tool like CAD to verify it. This is an open project case study, is a headquarter of Prometeia in Bologna. We did the BIM model of renovation or building, and we have to prohibit smoking inside the building and prohibit smoking outside the building, except in designated smoking area located at least 7.5 meters from all entries. So we developed our legenda inside the BIM tool, and we designed our smoking area, and this was the output that we use for LEED certification application. So it's not more a lot of data, a lot of workflow with data, but is a way to have the all information about LEED inside the BIM model. Also, the BIM for rating 3 is use the BIM authoring tool plus visual scripting tool. And this is another example case study of open project. So the credit material and resources, so building life cycle impact reduction. And this is the workflow, is a little bit complicated. So put all information about the EPD from LCA inside the material in Revit, in the BIM tools, and then export it in a data management tool like Excel through visual scripting like Dynamo, and go back to the BIM model, and also calculate the environmental report for the LEED credit calculation. So this is the BIM model, and the process to add the material information, so material parameter about the LCA information, like here in the identity data, all the phase of LCA. And then we developed a spreadsheet, and we put all this data in the spreadsheet, and then we have also this data another way in the BIM model, and we calculate all the quantities of the material and how is the LCA impact. And the BIM for rating 4 is when you can use the BIM authoring tool basic commands to verify a LEED credit. So, for example, there is also the building life cycle impact reduction, but not for new building, but for renovation building. And for LEED, there is an option, the option 3, that is that has different rules to calculate this building life cycle impact reduction. That is to calculate the percentage of reused materials. So the same case study of before, the headquarters of Prometeia. Here you can find we modeled the existing structural model, and then we modeled the demolition part, and then the new we modeled also the new part, new structure of the project, and we did it with the phases of Revit. That is a particular command in Autodesk Revit, and this command allow us to to calculate how the percentage of material that we reuse it, and then put this data directly in the lead online schedule. The BIM for rating 5 is use a BIM authoring tool with specific lead plugin to verify the lead credit. And the example is indoor environmental quality daylight. So the simulation of daylight autonomy and annual sunlight exposure. There is a plugin inside Revit that is Autodesk Insight 360, and putting this information about project, glazing, and material, you can have this plan view with the daylight analysis of this of the project, and also schedule with the information of percentage of illumination of daylight areas, and also windows with also the number of points, so the credit points for LEED certification. So is the best score, the best rating BIM for LEED, because it's completely integrated in the BIM authoring tool. The next step, and then I'm going to conclude, is going to the conclusion, is structure the BIM data to insert them automatically in the lead online spreadsheet. But it's a next step if we think in the currently state of the art. So all the previous methodology that we found here was under BIM level 2 maturity level. So we have file plus libraries, we have this different software, we have this workflow complicated with interoperability in different software. But the future of interoperability is cloud BIM. So have our BIM model in cloud and work with this model in cloud. That is the concept of level 3 cloud BIM models. So the industry now is moving to BIM level 3, which helps automate the integration between BIM and sustainability certification. For this, if we think to BIM level 3, we can use the use case requirements and develop an ontology. So take the existing ontology, develop modular ontology plus enrichments, and do ontology harmonization. So in this way, with ontology, that is essentially rules that explain that explain what the LEED certification asks to us. So a reason to develop an ontology is create a common understanding of information among people, enable reuse of domain knowledge, make a domain's main assumption explicit, and separate domain knowledge from the operation knowledge, and analyze domain knowledge. The idea of this ontology development is this example of possible IGBR framework. So starting for BIM-based building design, where we have a design team with stakeholders that develop a BIM model in cloud. And also we have a semantic knowledge representation of all the rules about green building rating standard. So like we see before, all the rules and also the algorithm that help us to verify a credit, and put it in a language that is possible to understand from machine, like a semantic web rule language, and put all this information inside a green building design data, and find a way to verify these rules automatically, with just a reasoning engine and find in real-time green building scores and give a real-time feedback to design team. So this is a framework or an example of the process that could be in BIM level 3. Also, the Building Smart International is going to in this way, because they're using the IFC OL, that is a web ontology language. So using the IFC OL, one can represent building data using state-of-the-art web technologies, so semantic web and linked data technologies. Thank you.
Thank you very much, Giacomo. There is a question for you. Do you already have an evaluation of the times this interoperable tool could save when it will be put in place in the end? The amount of time that you could save thanks to that.
No, we don't have an evaluation of time, but we know that this kind of activities of credit calculation, it's take a lot of time right now, because a lot of information that right now not in traditional process, in traditional project, you have to take this information from a 2D drawing or from Excel, so spreadsheet, and put it together and copy it in the online application for LEED certification in a very long process. So for sure, this kind of activity can help us a lot, like 30%, 50% of the time.
Okay, that's huge.
Yeah.
Okay, thank you very much. There is no other question. Thank you for your presentation, and we can jump on the last session of this session with Laura Vandi, the Focci, on an analytic approach for the identification of technology to be integrated in façade. So I will make you presenter, and you will have the floor to present your work. Thank you very much, Laura.
Okay, thank you. Just a second.
Yeah, that's working. It's in full screen.
Yeah, can you see perfectly screen? Okay, perfect. Good morning to all of you. I am Laura Vandi, the Innovation Project Manager of Focci Group. Thank you for your attendance, and today I'm going to present you an analytic approach for the identification of technologies to be integrated in the facade prefabricated unit. In particular, I'm going to talk about the renoZEB case of study. As you can see from this slide, this activity has been developed within the renoZEB project, which is a proposal to the European call named Horizon 2020 EEB 2017. renoZEB project started in 2017 and it will end at the end of 2021. The Horizon 2020 call regards the development of the near zero energy building renovation. In particular, it talks about the strategy for the deep retrofitting and the technology for building efficiency. renoZEB project involved 18 different European partners, and the project coordinators is Michele Vavallo from Solintel. Focci Group is responsible for the plug and play facade, which is a crucial theme for the renoZEB introduction. In fact, I will talk about the plug-and-play facade in the following slide. Focci Group is an Italian company leader in the envelope, building envelope. In particular, Focci deals in the designing phase, engineering phase, manufacturing and installation of building envelope for bespoke building. Just to give you an overview of the renoZEB objective, the project aim is to establish a systematic methodology for the energy deep retrofitting, in particular for building stock market. This objective is achievable by developing a BIM-based platform and tool for actor and value chain. renoZEB project based on 4 pillars, which are the reduction of energy consumption, reduction of cost and risk to the retrofitting intervention, the replicability and adaptability of the methodology in the building stock market, and increasing the property value of building after the renovation intervention. As I said, the plug-and-play facade is the main characters of the project, because it deals with prefabrication and modularity themes. The plug-and-play facade is useful because it allows to reduce the cost and the time of the intervention, and it answers to the renoZEB project expectation. The important theme is that I'm going to show in for this methodology is to move from the plug-and-play facade concept to the designing phase of the plug-and-play. Again, the plug-and-play allows to link different technologies, and as you can see from this slide, they are listed different macro technology components, which are window, multifunctional insulation boards, ventilation unit with heat recovery, building integrated photovoltaics, building integrated solar thermal system, intelligent facade controller, clicking fixing mechanism. But the main question that we tried to give an answer is how is possible to select different products which are in the market? Because in the market we can find thousands of products for the same technologies. But how is it possible to select the most promising products which reply to the renoZEB expectation? The methodology that I'm going to show you is divided into different steps. The first one is the development of a multi-criteria decision matrix, which is cross to the analysis of the boundary condition of the existing building. What we are going to find is the plug-and-play facade design. The first step, as I said, is the multi-criterion decision matrix. As you can see from this slide, this is the developed matrix, which is divided in 4 main parts. In the first one, in each line, are listed the matrix requirements, which are linked to the renoZEB expectation. In bold are selected the main and most important requirements, while in italic there are eventually some sub requirements. I listed in the slide some of them, which are related to the renoZEB concept. There are some of them are industrialization, less intrusive system, or ventilated facade, plug-and-play facade. or again, the development of Smart ID facade module. The second part of the matrix is related to the products. In fact, as I said in the previous slide, has been selected different macro technology. For each macro technology in the matrix, we have put 4 or 5 products that has to be compared related to the requirement. The third part of the matrix is the score system. In fact, for each product, we have evaluated in comparison to the requirement. The table shows the score system. The empty points, it means that that requirement is not applicable for the product. 1 point is a low score, as a low evaluation, and the 3 points are the high score that we can give to the product. The last part of the matrix is related to the result. In fact, we have developed a multi-criterion decision analysis, which is the mathematical sum of the score for each market product. The first part that we have done is related to the facade system technologies in order to understand which system was better to use for renoZEB project. So we kept in consideration 4 different systems. The first one is the external re-insulation, which is the less intrusive system, which allows to reduce the U value of the existing facade. The second one is the double skin facade. This solution is mostly used with glazing facade, and it allowed to insulate the heating from in the hot season. The third system is divided into subsystems, which are the stick system and untitled system. So I reported in the slide the matrix that we have used for the selection of the best solution for the facade system. In column, there are the system, and in line, as I said, there are the requirement. What we have, the result that we have found is that the curtain walls, the unitized system, which is a part of the curtain wall, is the best solution to use for renoZEB, and this is what we have done. The second part is related to the component of the plug-and-play facade. We have already seen all of these macro technology, and for each of them, we have developed the matrix. I'm going to briefly show you what we have done. So for each macro technology, for instance, the prefabricated window module and roller shutter, we have defined 4 of the main products that we can find in the market. We have compared them related to the matrix and find the best solution for renoZEB. So we have done it for the prefabricated window module and roller shutter, multifunctional insulating board, ventilation device, and so on. So here you can see in the slide the different metrics that we have developed for building integrated solar thermal, hybrid solution. And I wanted to show you the result of this methodology, the first step of the methodology, which help us to understand how it could be possible to move from the renoZEB concept, plug-and-play facade, to the concrete, to the real designing phase for the plug and play. So here you can see from the macro technology which product gained the highest score in the matrix. An important point is that we need is a qualitative approach, but a crucial importance is to cross the multi-criteria decision analysis for the envelope system to the multi-criteria decision analysis of the envelope system component. Because, for instance, I took as example the multifunctional insulation board. The telescopic ducts, it was not the product which gained the higher score, but we need to keep in consideration that this product was the only one that could be used for the plug and play envelope system, which is the curtain wall, and so on. The second question is, what are the pitfalls for building envelope in the retrofitting intervention? As I said, renoZEB project divided in, the main theme of the renoZEB project is the plug and play. So once we have defined the technology for the plug and play, there is the facade integration, but this plug and play facade has to apply to the existing building envelope. So the second step is the analysis of the building envelope in order to find the boundary condition for the designing process. We need to keep in consideration that we deal with an existing building and analyze the load-bearing structure, the existing opening, the thickness of the facade, the typology of the building, the typology of the foundation of the building. And then, when we have defined a baseline for the building envelope, we need to set up primary panels for the plug and play facade, which are related to the window unit because they are fixing element. The second part is the secondary panel, which are the opaque one, and the third part is to keep in consideration an eventual aggregation of the unit. Here you can see the two demonstrators of the renoZEB project, because the finalization of renoZEB project is to apply the plug and play facade in an real existing building. Here you can see the building located in Boru, Estonia, and on the right you can see the Durango building based in Spain. Again, the plug and play facade present a modularity, and thanks to the prefabrication intervention, we could set up a catalog for the plug and play facade. So you can see the unitized facade system, which could have different dimension or different frame based on related to the window, or if there are some window, or if there are not some window, and then it could be chosen even the finished materials. As a result, for the second step, this method which I presented underlying key element for the design process. So have I said, it's important to define a baseline for the envelope condition. The second one is to develop a framework definition related to the dimension of the unit, or if there are any window or not. The third part, the multifunctional insulation system of the plug and play facade, It depends by the retrofitting intervention and the component that the intervention want to have inside the plug-and-play facade. Could be just insulation, or as for the renoZEB project, the multifunction insulation system could be component by different technologies. The cladding system, as we have seen from the catalog, could be different, and they are related to the cost or the quality on the color of that the architects want to achieve. The cladding system could be also in wood, in fiber cement, and so on. The last part of the key of the guideline is the module aggregation, in order to have a optimization of the logistic plan, and even for the transportation, for the installation, or for the manufacturing activities. The conclusion of the methodology that we have discussed today, that for us the methodology represents a valid solution in order to select the most promising market product that you can find in the market. And the method defined a guideline for the designing process. What the disadvantage is that the method represent is that the approach is just a qualitative approach, and it should be further implemented with a more quantitative approach, especially for the engineering phase. I wanted to put in the slide also these pictures. As you can see, this is the visual mock-up for the renoZEB product, which has been manufactured from Focci here in the manufacturing place. You can see that the plug-and-play solution could have different cladding finishing, or even technology, has a PV panels or solar panels, wooden cladding panels, or fiber cement, and you can see all of them in this picture. Some details, the monoblock and the section. Yeah. This was the methodology that we wanted to present you. If you have any question, I would be more than happy to reply. So thank you for your attention.
Thank you, Laura, for your presentation. And yet there is a question, I think, from Valentina.
Yeah.
Valentina, if you want to ask your questions.
Yes, sure. Thank you, Laura, for your presentation. I think this project is really interesting. I have a couple of questions, actually. One is about the metrics. So
yes.
Is just the designer using these metrics when he approaches the choice of building technologies, or these metrics could be used also by product manufacturer or solutions provider to, let's say, qualify their offer in terms of your plug-and-play solution? So it's something that can build the database, let's say.
Yeah, thank you for your question. It's really interesting. So far, we have used the methodology, these metrics, just for the design phase. But this is a good point, because this metric, it could be further implemented, and it could also be used for the manufacturing activity. Yes, of course.
Okay, and so I come to the second question.
Yeah.
Among the criteria for the choice of the solution, did you take also into account the cost per square meter? Because I guess if this type of renovations should hit the market and allow a broad renovation of the building stock, probably a cost-efficient solution should be advisable. And I'm not really aware about the cost of these unitized modular facades. if or cladding system, if it is cheap or expensive. I'm wondering if you have already taken into account this point.
Yes, of course. We have, as I said, one of the pillar for renoZEB is the reduction of cost, because as you said, we deal with the stock building market, and in the requirement of the products, the third point is the low-cost multifunctional insulation board. So yes, it has an important role in this project. Just to give you an idea of the price and the cost, it's just a draft for the cost. It should be more or less 600 euros per square meters.
Of facade.
Yeah.
Okay. Thanks much.
You're welcome.
Sorry, I have also a question on my side. Who provide the data for each product that you put in the matrix?
I mean, we have developed the matrix. The data related to each product, we, in some cases, some partners has provided data, or otherwise we just call some company or just find the information on the website. So it was a result of activities, not just from our point of view.
Oh, okay. And if this matrix become a tool that a designer can use, do you plan to update it maybe each year to have all the new products that come on the market? Is it something you already have in mind?
Not yet, but of course the column of the requirement has to be in line with the retrofitting intervention expectation. So those requirements are for renoZEB, but in general could be even implemented or changed for different projects.
Okay, thank you, Laura. It was a great presentation, and yes, this plug and play facade is something that the construction sector is dream of from a long time. So yeah, good luck with your project. And I would like to thank all the intervenants in this session. It was all very interesting to hear from you and all your projects. Sorry. So at the end of our session, so there is no more questions, so I can close now the session. And yes, thanks all the intervenants. And maybe you have noticed that one of our sessions was cancelled, unfortunately. We are sorry for that, and thank you for your attention. Bye.
Thank you, everyone. Bye.
Thank you. Bye.
You. Bye.
And thank you, Rachel, as well.
Yeah, thank you. Bye.